types of sequences. Let's discuss first harmonic sequence. What do we mean by harmonic sequence? Harmonic sequence is a sequence of numbers whose reciprocals form an arithmetic sequence. For example, if we have 1 over 5, 1 over 8, 1 over 11, and so on, this is a harmonic sequence because its reciprocals form an arithmetic sequence. 5, 8, 11, and so on. Now, in finding harmonic sequence, or the nth term of the harmonic sequence, we use the formula of the arithmetic sequence. For example, find the 33rd term if the 8th term is 4 and the 14th term is 4 over 19. In this example, the given are a sub 8, which is equal to 4, and the a sub 14, which is equal to 4 over 19. The unknown here would be a sub 1, d, and a sub 33. To solve this, we use the formula of the arithmetic sequence. That is, a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. But remember, before we solve this, we need to take the reciprocals of the given. So, we have a sub 8, which is equal to 4, becomes 1 over 4. And our a sub 14, which is equal to 4 over 19, becomes 19 over 4. So, let us now solve. A sub 8 is equal to 1/4. Using the formula a sub n is equal to a sub 1 plus the quantity of n minus 1 times d, we substitute the values. We have 1/4 is equal to a sub 1 plus 8 as the number of terms minus 1 times d. Simplifying this, we will have 1/4 is equal to a sub 1 plus 7d. And this one serves as the first equation. Let us use the other given, a sub 14, which is equal to 19 over 4. So by using again the same formula, we will have 19 over 4 is equal to a sub 1 plus our n becomes 14 minus 1 times d. Simplifying this, we'll get 19 over 4 is equal to a sub 1 plus 13d. And this one serves as the second equation. Now, to find for the common difference and the first term, we need to subtract these two equations. So, we have 1/4 is equal to a sub 1 plus 7d minus 19 over 4 is equal to a sub 1 plus 13d. So, remember, in subtracting terms, we need to change the sign of the subtrahend and then proceed to addition. So, we'll get 19 over 4 becomes negative 19 over 4. Our a sub 1 will be negative a sub 1. And our 13d becomes negative 13d. And then we'll add. So we have 1/4 plus negative 19 over 4. That would be negative 18 over 4. A sub 1 plus negative a sub 1 will be cancelled. And then 7d plus negative 13d will be equal to negative 6d. And then simplifying this one by using multiplication property of equality or MPE to eliminate negative 6 besides d, we need to multiply the whole equation by the reciprocal of this negative 6. And that is negative 1 over 6. So our d, our common difference, is now equal to 3/4. So since we have solved our common difference, it's time for us to solve our first term. So it's either we use a sub 8 or a sub 14, we'll get the same answer. But this time, we will use a sub 8. So again, our a sub 8 is equal to 1/4 equals a sub 1 plus 7d. By substitution of the obtained value of d, we will have 1/4 is equal to a sub 1 plus 7 times our d is equal to 3 over 4. So we will have the value of a sub 1 as negative 5. We have obtained now the values of the common difference in the first term. We can now get for the 33rd term of the sequence. So we use again the formula a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. Let us now substitute the values. We'll have a sub 33 is equal to our a sub 1 is equal to negative 5 plus our n is 33 minus 1 times our d 3/4. So simplifying this one, we'll have a sub 33 is equal to negative 5 plus 33 minus 1 times 3/4 is equal to 24. So we'll get a sub 33 is equal to positive 19. But remember, this is simply the value of the a sub 33 given the arithmetic sequence. So therefore, we need to take the reciprocal of this for us to know what is the value of the 33rd term of the given harmonic sequence. So we can now say that a sub 33 is equal to 1/19. Which term of the sequence is 3/17 if the first two terms in the harmonic sequence are 1/3 and 3/10? So in this example, the given are the first term, 1/3, the second term, 3/10, and the a sub n, 3/17. What do we need to find? So we need to find for the number of terms or the term number. So to find this, we use the formula n equals 1 plus a sub n minus a sub 1 over d. But before we solve this, we have to remember that our given are the terms in the harmonic sequence. So we need to take the reciprocals of the given. Given a sub 1 1/3, it becomes 3. Given a sub 2 3/10, it becomes 10/3. And our a sub n 3/17 becomes 17/3. So before we find our n, we can solve first for the value of the common difference because the two given terms are given. So we have a sub 1, which is 3, a sub 2, which is 10/3, can be subtracted. So we have 10/3 minus 3 is now equal to 1/3. So it's time for us to solve for our n. By substitution, we'll have n equals 1 plus our a sub n is 17/3 minus our a sub 1 is 3 over the solved d is 1/3. Simplifying first, the given in the numerator, 17/3 minus 3 is 8/3. So to solve this more, we have n equals 1 plus 8/3 all over 1/3. So as you have noticed, we have formed complex fractions. So in this case, we need to take the reciprocal of 1/3 and then multiply this by 8/3. So we will have n equals 1 plus, you have 8/3 times 3/1. So we'll get 8. So now we have n equals 1 plus 8, which is equal to 9. Therefore, our 3/17 will be the 9th term in the given harmonic sequence. Another type of sequence is what we call Fibonacci sequence. What do we mean by Fibonacci sequence? Fibonacci sequence is a sequence where its first two terms are either both 1 or 0 and 1. And each term thereafter is obtained by adding the two preceding terms. For example, 0, 1, 1, 2, 3, 5, 8, and so on. This is an example of Fibonacci sequence. Why? We have 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. So if we're going to get the next term, we can have 8 plus 5 is equal to 13.